Hello everyone. So we'll be covering the GAN part into two modules. First module we'll be covering it today, and the second module we'll be covering it tomorrow in the next video. So let's start with what is GAN. Okay, so if you have seen ever the AI generated face that look reals, or have you seen an app that turn horse into a zebra? So that's what GAN works. Okay. So now first part is that what is GAN. So at its heart, a GAN is made up of two neural networks that are basically fighting with each other. One is called the generator G, and the another one is the discriminator D. Now the G's job is to take a random noise and turn it into a fake data that looks real, like a fake image. D's job is to look at the sample and decide that is it real or not. They are the training at the same time in what called a min-max game. G is trying to minimize its mistake, and D is trying to maximize its ability to catch the fake. Here's the key insight and honest and the coolest part of this, that instead of trying to explicitly take a model data, how should it look like calculating the exact probability about it, the generator just learn by getting feedback from the discriminator, forget it's trying to fool a critic. The forget doesn't know anything about the art theory, but they just try to get it better every time the critic catches them. Now why use GAN instead of other generative model? So we have already seen that the generative model like the VAE and the auto regressive models, but why bother about GAN? So some points about that are the sample quality. GAN can produce much sharper and more realistic images, and VAE can produce a blur image. Second is the training stability. This is where the GAN struggle, because it's a adversarial setup. Training can be unstable. So VAE are more stable since they are using a straightforward loss. Then we have the likelihood. VAE gives you an actual probability estimator. GAN doesn't. So that's an implicit and no clear density function also. Then we have the mode coverage. GAN can suffer from something called as the mode collapse, where the generator just keep producing the same few outputs instead of capturing the full diversity of the data. Speed also, GAN are faster, but just one forward pass through the generator and the sample. So basically GAN can trade some stability and theoretical cleanliness and speed also, and good visual quality. The segment 3 contain the GAN training pipeline. Let's walk through that how it actually happens. So you start with a random noise sample from some distribution. Then the noise get into the generator, which outputs a fake sample. Meanwhile, you also grab a real sample from your actual output, and both the real sample and the fake sample get fed into the discriminator. The discriminator output produces a verdict, real or fake, and repeat this over time and time. After each round, D gets updated to get a better and tell you that what is real and fake. G gets updated to get better at fooling D. So it's a back and forth. Okay. Now the maths behind it. So the original GAN objective is to return as a min-max game. G is trying to minimize, D is trying to maximize. This expression, the expected log probability D assigned to real data plus the expected log of 1 minus the probability of D assigned to the fake data. In plain English, D want to give real data a high score and fake data a low score. G want D to score more on the high fake data and less on the real data. One important detail is that in practice, instead of generating G minimizes the log of 1 minus D score, we usually flip it. So G directly goes to maximize the D scores on its fake sample. Why? Because in early training where G is bad, the original version gives very weak gradient, basically no use of learning signals. So this is a trick that is called as a non-saturated losses, and this is keep training moving in the early stages. Now before covering to the next part, I want you guys to have a brief about the architecture for this GAN diagram. You can refer a paper on this GAN that is being written, so that would be a great part. Today's lecture will be short due to my health issues, and in the coming videos we'll be covering the complete GAN also. Okay, so this is all from my side about the GAN, and we'll be covering it in the second part. Thank you.